So, hello everyone again and welcome to my channel. In here, we're going to dive into something quite spectacular, I must say, where you're going to apply all you know about enzymes, classification, and also names into a specific task, which is to determine the enzyme based on a given chemical reaction given. Like, for example, in here, if you look at this, we have number one, where we have an hydroxyl group right here, and this hydroxyl group right here is transformed into a ketone group right here. So in this case, what we can imply here is that this species performed oxidation, and then you actually identify the reducing agent, or the one that does the reduction, because now in this case NAD plus is actually causing oxidation but itself is reduced. So this is a reduced species where it's actually involved in the change in its chemical structure from no hydrogen to hydrogen present right there. So as a result, we generalize this overall reaction to be called the oxido reduction, or a redox reaction. So as a result, the enzyme that will be involved in this reaction is called an oxidoreductase. And once you're able to identify that, then we can actually look for the systematic name that is assigned to this particular type of enzyme. And since we know that in here we have the species which is actually involved in the oxidation, or I would say the species that is oxidized, we know that to be alcohol, so that stays first, alcohol. And then we know our reduced species in this case is called NAD plus. Then we can actually put those together, and then after that we put down our enzyme name, general name, which is oxidoreductase. Or there is another name that is assigned to reduce or redox reaction enzymes. Another name is to just use the species that actually performed the oxidation. So as a result, it loses hydrogen. So therefore, we actually say alcohol, which is the one that loses the hydrogens, and then the enzyme is name is following the general name as well, which is also a dehydrogenase. So dehydrogenase. So this enzyme right here is pretty much what you see in this particular structure here, which is just showing all the alpha and beta sheets right there, alpha helix right there as well. So it's just interesting to see that. I mean, I took it from Google in a way, so it's kind of nice to see that actually published right there. So next one is another example, which is using a particular compound with a nitrile in there and the presence of water. Take note of that. It's actually transformed into a carboxylic acid group right there. So in this case, what we can imply is that since water is used in this particular reaction to break or cleave this specific bond right here, then we can actually imply that this enzyme here is actually known to be a hydrolase related enzyme. So it's a hydrolase, and since it's an hydrolase, then if we go with the systematic name, we can go first with the one that is actually involved first with the one that is actually broken, and in this case we have the nitrile that is affected by water, and then the next one is to identify the group that is actually involved in the elimination process, which is called the amino which is kind of related to nitrogen, which is what we have right here, and then we actually put the general name, which is hydrolase right there. So in this case, you can also write that, or you can just write nitrolase. Nitrolase. So in here, you're showing the substrate name here, and ase, instead of putting E as the suffix, you just put is at the end in there. So that is where this nitrilase comes from. So this here is actually an application where you can actually find this code, which is a E3 species right there, comparing that to the one that we have here, which is just the EC1 right here species for the first reaction. So EC3, EC1, and the next one here is another reaction here. This is the full reaction where we have this particular type of I would say almost looks like an amino group, but no, it's not, because in here we just have carboxylic acid on one side with a little bit of carbonyl group right here, and then we have a carboxylic, I would say carboxylate in a way at the other end of the terminal. So this compound here is known actually to be called 2-oxoglutarate, and then this particular compound right here, you notice, is an amino group right here, and here we have our carboxyl group right there, and in here we have our R group pointing right there, which is just a methyl group. So this is considered to be a amino acid type, which is called the D-alanine right here. And what happens now is that what you notice is that in here we have the alanine nitrogen section right here actually moving over and kicking out the carbonyl group right here around this region right there, that causes the insertion in here of this particular product here, and then forming a new type of an amino acid right here, where you have the nitrogen, which is the amine group, and here we have the carboxyl group right here, and then on this other side we have our terminal section right here, which is the R group right there, and this is actually called the D-glutamate amino acid right there, and we have our product of this particular species region here, which goes out and interacts with this other carbon right here with the oxygens right there to form a pyruvate. So due to this process of one particular group right here actually being the donor, which is the D-alanine right here, because it's donating right here the amine group into the 2-oxoglutarate. So what we notice is that this here becomes the acceptor, and this right here is the donor. So as a result of that, once you're able to identify the donor and that of the acceptor, so in this case we can actually determine the name based on the reaction that is formed. Once you have a donor and an acceptor, this is actually considered to be a transferase enzyme related action. So once you're able to identify that transferase, then you can then identify the donor species, which in this case is called the D-alanine, and then the acceptor, which is 2-oxoglutarate. oxoglutarate, and then don't forget the group that is involved in this particular action or movement, which is called the amino group. So, and finally you identify the general name, which is transferase, which is the enzyme that is involved in it. Now we're done with that. We're going to go into the next one, and if you want to get the name of the code, I think the code is like EC. Since it's transferase, then we expect it to be 2, and then we can just like other subclasses and stuff like that actually goes with 6.1.21. So that's about it for the third one. And the fourth one here is identifying something quite interesting, which is a type of an elimination reaction, where you notice here to see that you're going from this particular amino group here and it releases ammonia, but then the main structure of this compound changes from just a single bond to now a double bond. You notice here that a double bond is formed, so this is known to be a type of an elimination process, and elimination process is highly linked to a specific type of enzyme called lyase. So this enzyme is actually involved in elimination reaction, and so to analyze or give the name of this particular species, this actually you notice is that this is actually a carboxylic acid group, this is the amino group right here, and then you have your R group here. This is similar to what you have for the L aspartate. And once you have that, then you can just go with the substrate, the eliminating group, and then lyase. So the substrate name here is called the L aspartate. Eliminating group is the amino group. So in this case, we just say since it's eliminated to form ammonia, then you just put ammonia as the product in there, and then you just put the enzyme general name, which is lyase. So this in here is the enzyme that is involved in the transformation or the elimination of your enzyme of your amino acid group to become a reduced form of the amino acid group right there. So once that's out of the way, we're going to go into this next one right here, and in here we have another species, which is another form of amino acid group. Here we notice the carboxyl acid group, and we have the amino group right there. In here we have our R group. This is similar as well to what we had previously at the top, but this time in here we have ammonia present, and in the presence, take note of ATP, which is hydrolyzed to form AMP and diphosphate. Then you're able to produce another type of amino acid right here, where you notice that in this region here is changed into a type of an amide related R group in the carboxylic and the amino acid group right there. So in this case, what you see is that there is a transformation. Let's put the name here of this from a well-known, I'll just put it here, to be called aspartate. You remove the A to the product, which is asparagine. So as a result of that, what we see is that we have ammonia here, and since ATP is involved in this particular, I would say, form of bond formation here, then we actually know that it is not lyase. Instead, it is known to be a ligase. So as a result, we can actually get our substrate 1. This is our substrate 1 and this is our substrate 2. So substrate 1 is known to be aspartate, and then or a type of aspartate called L. It could be L or D. In this case, we just put L. And then the second substrate is known to be ammonia. And then you go with the name ligase because ATP is involved in there. However, you can go in another route in here where we actually go with the product name, which is in this case L-asparagine, which is the product here, and instead of putting the name synthase, you just put synthase. So the lyase in this case is having the product name and then synthase, but for ligase it will be the product name but synthase. So that is a little bit of a difference between lyases and ligase. Ligase is because ATP is involved, we go with the name synthetase, and the other one vice versa is the opposite. So sorry for a little bit of paranoid state of mind today, kind of like just wanted to get that out of the way. And then finally we have this one right here. You notice that the chemical formula on the left side is C6H11PO9 with a negative charge, and the same thing here with the product C6H11PO9 negative charge. So in this case, the chemical formula is the same, but we're having different structures. The one on the left side is actually known to be a D-glucose, but in the cis carbon there is phosphate right there. However, an enzyme actually transforms this to another type of isomer, which is in this case a fructose. I'll call it D. Fructose. On the cis carbon we have phosphate. So in this case, what we can actually imply here is that this is isomers where it is a back and forth reaction there, but with the help of the enzyme you actually get into the fructose form of the phosphate. So as a result of that, what we get is this particular name where we have the substrate isomer name and then you put isomerase at the end. So in this case the name will be the glucose 6-phosphate, and then since it's an isomer, then the isomerase is the enzyme that is involved in the transformation from the fructose form to the from the glucose form to the fructose form, and this is the specific structure form of this particular enzyme right there, with I think a lot of alpha helixes right there. Interesting stuff. So that's about it for this particular video. Please hit a comment down below. Let me hear your thoughts about this long explained video on how to name enzymes based on the chemical reaction that is presented to you. All the same, hit the comment, share and subscribe. By that way I can talk to you later. Stay smart and believe in yourselves.